All right, welcome back. We are at chapter 11, and this is week 11. And this week we'll talk about instrumentation and control system. Probably you remember from the last 3 weeks we talked about combustion control, instrument, how do we regulate the firing rate, also how do we automate the firing rate and the operation inside the plant as much as possible. The more automation we have, the more precise and steady operation we have in the plant. So we'll talk about the instrumentation, boiler control system, which is also building up on chapter 10, 9, and 8. I will try to list most of the instruments that we will work on. Of course, don't get overwhelmed with the amount of instruments there. You'll be pleased to know that there is a specialist for each instrument. Once you assign a role in a power plant, you will be assigned to a set of instruments in an area. Nobody's supposed to know everything about the plant, but it's helpful to know how do they work, how do they function in a bigger picture kind of thing. Okay, so we'll start with chapter 11, instrumentation. These are our objectives. We'll describe type of instrument in the power plant, components of a control loop, how do we achieve control. We talked last week about how do we have a control that has been built and designed to have input and output. And I'll use the car example for control a lot because it's something we always interact with and we are familiar with. The purpose of control panels, what are we looking at, what is going on there, what kind of messages we see. Final element for adjustment. We'll talk about the operation of digital control system. So I will start with some of the basic things that we will need as indication, and it's going to be our input. So this is one of them is the pressure gauge. So we'll start with instrument. Pressure gauge. I hope this font is clear. A pressure gauge is one of the main things we have inside our boiler because it's an indication of how much pressure is inside the pipe or the boiler. And again, it's very critical to know what is the pressure because we want to achieve certain pressure of steam when we try to work with steam turbine. You have a lot of steam pressure gauges in your car. There's an oil pressure gauge. There's also in some new cars tire pressure gauge, which basically measure the pressure inside the tire and send you a signal into the control for the car to tell you if the tire is low in pressure. We also have fuel pressure gauge as well. So pressure gauges, they come in different shapes and colors. These are mechanical pressure gauge. It has a membrane that pushes against the pressure stem here and shows you what is the pressure inside the tank. Some of those are also digital. They work in different configuration, but they do the same function. So as they say, different ranges, so we can estimate the amount you have. Sometimes it shows on it whether it's from 0 to 15 psi, so this is small range and this is large range. So probably you want to have both to have an accurate reading of what the pressure you have. And if you notice here, there is something up to all the way to 400 psi, which is huge. But you will see these kind of pressure gauges on boilers because we're working with high pressure steam turbines. So pressure gauges from small scale to a large scale. This is another type of pressure gauge that has a siphon. The siphon is trying to protect the pressure gauge from having any excess water coming into it. It's how it's designed, and we want the pressure gauge to work with only steam. We don't want any liquid coming inside the pressure gauge. So you will see some of them that require to have a siphon coming through them, so they will not have any water coming inside the pressure gauge. Draft gauges also measure pressure. However, for draft, usually it works with water, and sometimes also it can work with steam, but I've seen it mostly with air. So the draft basically measures the pressure between 2 points. And I don't want to go too much into the air pressure, but when air flows through a duct or through a pipe, 6-mile pipe, we have 2 types of pressure. One of them is acting on the wall, it's called static pressure. and there is something called acting on the fluid here called velocity pressure. And we have something inside here that's called total pressure. So the main, let me write this right. The main purpose of us trying to use pressure gauges inside a duct or a tube is to measure the velocity. Why do we need to measure the velocity? Because we want to know how much air or gas is flowing through that pipe, so we can gauge how much draft is coming out or inside. So probably if you work with some kind of duct system, probably you have to use pressure gauge to measure the air velocity. With having the velocity, you can measure the flow rate. So this is the flow rate of any fluid. That is velocity multiplied by area, the cross-sectional area of whatever the fluid is running from, and that will give you the flow rate, and the flow rate usually is volume per time. So it's either cubic feet per minute, cubic meter per second, and so on. Some compound gauges tell you like vacuum or a combination of more than one gauge. Temperature is usually measured in either Celsius or Fahrenheit. That's very simple to do. And again, we have some mechanical ones with either some kind of liquid going up and down, and sometimes we have more precise one that are using electronics such as thermocouples, for example. So they tell it's an indication of the temperature, and you'll usually see Fahrenheit and Celsius. There are other measures of temperature that I don't think they are used, that are, for example, Rankine cycles, or I forgot the other one, Rankine something else. But anyways, this is the most two common ones, Fahrenheit and Celsius. Thermocouples, we mentioned thermocouples, and it's thermocouples is two wires that produce small, two dissimilar wires, different material wires put together, and they produce voltage when they are exposed to heat. So they are very precise, they're very well calibrated, and they also can measure temperature over a high range of temperature, and their sensitivity do change from one type to another. RTD, it's resistant temperature detectors. They work differently. They don't have thermocouples. They have some other chemical material inside here that will change resistance based on temperature. So it's another electronic way that will change, that will send an indication to the control to indicate the temperature. So we have regular thermometers, thermocouples, and RTD. They're also sometimes called thermistors. Thermistors is the same idea. Bimetallics, we talk about two metals, thermocouples, we do the same thing. They can indicate temperature. Liquid and glass, these are very common. This is like old-fashioned thermometers, and sometimes we would like to have redundancy. We would like to have something electronic, and also we would like to have one of those old-fashioned ones, because we want to make sure that the electronic one is not giving us the wrong reading, so it's good to have confirmation. These are very reliable. They hardly ever break, because once you calibrate the liquid inside, it's going to be the same no matter what, unless it breaks or leaks. Floats, they indicate the water level. Different kind of, we talked about displacer before. Again, it's some kind of liquid level indicator. Again, these things come in different shapes and different display, so don't just look for one shape and expecting it to be all the same. Pressure measurement, again, same thing. Some of them we can combine the pressure to know the fluid level. We talked about that in week 4, and we said that the height of the water determines the pressure. So we can use pressure gauges to determine the water level inside the tank. How is that done? So basically, we can multiply, to know the pressure of the water at this point. You'll multiply, pressure will equal, probably can't see it here. So pressure equal rho G H. This is the constant number. I think it's 43 something, and the height is how much height in that tank. By knowing that height, you will know how much is in the tank. That depends on what the tank look like. So if the tank is cylindrical, it will be easy to know. If you know the height, you can know the volume. So the volume of that tank will equal height times circumference, which is 2 pi r. That's the radius. Simple arithmetic. Usually it's done for you, so you don't have to go through that. That will give you the whole calculations. You keep it in the gauge. So based on the height, you can know if the tank is full or 50%, 50 or less than that. This is very similar to sometimes what you have in your car. Your car tank has a float inside the gas tank, and that float can tell you, based on the level, how much you have, half, full, and so on. More instrument. Again, it's for level. So basically, it's an ultrasonic. It sends a signal to the level of the fluid and tell you how high the fluid is. Bubbler is another way to know the pressure inside the tank. Again, these are all instruments to measure the level, and these instruments keep improving day by day, so probably now you'll find more advanced stuff with less involvement and more control. Differential pressure flow, they measure the pressure drop between this gasket. So there's a pressure here and a pressure in this sensor in this area, and by knowing the difference in pressure in those two gaskets, you know if there's a leak or not. So this is a way to try to measure the flow. Flow of a piston. Let's see what else. Metering system. Those are very important to measure how much flow is in a pipe. So this is a positive displacement, which means this compartment gets filled up and it will turn on a wheel. Based on the number of wheels, based on the number of turns of these wheels, we can know how much flow is going through the pipe. Flow meters, again, they have different strategies and different ways to measure flow. This is one of the most basic ones. Is we know the volume of this compartment, and based on that we can know by how many times it turns, how much flow went through the pipe. Coriolis meter does the same thing. Probably these are very common, and there's a spinning mechanism here that will measure the fluid flow. Where do we need to measure the fluid flow? For fuel, for water, and also sometimes for steam and air. This is a system analyzer that will analyze the contamination inside the feed water. Conductivity, that's very useful instrument to use inside the tank. If you measure the conductivity of the water, what does that tell you? Tell you it has more salt. So based on the conductivity, we can know how much salt and dissolved matter in the water. pH measurement, again, that's something that can be either done live or through a test. Stack analyzer, this is also interesting because it measures the thickness of the soot inside the plate. So if it gets too thick, then it's time for you to turn on the brushes or the steamer. Gas analyzer, they also analyze the gas and how much is coming out of the stack. Zirconium oxide oxygen analyzer. This is actually something for combustion. It tells us how much is our efficiency inside the tank. So basically, zirconium oxide is something also you have in your car. You have two of those, one of them in the air intake and one of them at your exhaust. So what happens, it measures the amount of oxygen that's coming in and out, and based on that, you can know how efficient is your boiler and what is the combustion happening inside the boiler. Opacity, measure the attenuation of light source as the light passes through the sample. So opacity measures, they are common, but they are not used as the main ones because they measure the product or the steam based on the transparency of that steam or also water or fluid. They are used, but I haven't seen them as the main source of feedback. but they're very common. So controls are over the boiler, and all these controls send signals to the main controller, and based on that, you can manage your firing rate and manage the output and input. So nowadays, probably you'll see a touch screen and you'll see commands and indications, and all those reading that you get from the sensors come all the way to your control panel. So you can monitor what's happening, and you can set the high and low limits. Okay, let's say for example I want the steam to be between 3 and 330 psi, and so on. So you can manage those things, and probably you'll see a lot of alarms if something goes wrong. And it gets a little bit involved to program this, and again, it's not something probably you will have to do right away, but at least you know that there are some signals, and it will tell an alarm. You'll see an alarm if something is disconnected or something is not functioning. Again, we need to record all the data that comes out of the plant, as long as it's not mothballed. If it's a live plant, even if it's idle, you need to always record what's happening. Based on those data, you can analyze what's happening inside the plant and what are the risks. There is so much data, and sometimes there is some consultant who come and analyze your data, and they can tell you or tell the plant manager that this is an area of improvement and this is a loss of efficiency and so forth. So that are very important. Control valves, they used to be pneumatic, where basically we use pressurized air to try to open and close valves remotely, so we don't have to go there and manually do it. So it's composed of an air supply here, which exerts some pressure on a diaphragm, and the actuator here will close the valve or open it. A lot of them are still in the field, but they are being replaced by motorized valves because they're more precise and easier to work with. Actuators, again, it's a name for the part of the valve that moves either with air or by a motorized motor. A pilot, again, is another regulator for the gas. So the more instrument we have, the more precision we have in the flow rate of the gas coming into the pilot or the main flow rate. It's very overwhelming how much instrument is there and how much liability and reliability expected from this instrument, and that's why they cost a lot of money, and that's why also they require a lot of training. So they want somebody that trained on each specific equipment. And also, it is also worthwhile to visit some of these companies' websites. Sometimes they do offer some trainings pertaining their own equipment, and a lot of the times these trainings are free, so look into it. Dampers, they move also automatically to open up air and close up the air supply, and they're also motorized and can be remotely controlled. So in the control room, probably if you visit some of the local power plants, the control room has a connection and display for every instrument in the plant, and it will minimize the walking around the plant. Plants are very huge, so to do a checkout and go and walk around and check things, it's time consuming. It's still necessary to be done, but we can control and monitor everything from the control room screen. But as a trained operator, you'll start to see the number doesn't make sense, and sometimes you might need to go and see what is actually happening physically in the components. Transducer is a name for something that will transmit information either wirelessly or through a wire to the control panel. This is some transducer that will send the information all the way to the control panel. This has been now a new practice where you can send your house gas meter information to the power company directly, without the need for somebody to come every day or every month to take a reading. All right, this is what we have for an instrument. Try to read the book, and this is chapter 11. And I know it's a little bit overwhelming, but try to just get exposed to some of the most common names for this equipment. Of course, it's really difficult to remember all of them, and as you work with them, if you do work with them, you will be able to remember the names and how they function with each other. All right. Thank you.